let's look at the third Tds equation. First, first. All right. Now let's look at the third Tds equation. Now, the first Tds equation is, we said entropy is a function of pressure, a function of temperature and volume. The second Tds equation, we said entropy is a function of temperature and pressure. So the third Tds equation, we say entropy is a function of pressure and volume. All right. So of course, we take the derivative of both sides. So we are going to have the s to be equals to, going to have the s to be equals to the partial derivative of s all over the partial derivative of p, keeping v constant, the p, plus partial derivative of s all over the partial derivative of v, keeping p constant, then the v. All right. So if we have this, now the next thing we are going to do is we are going to multiply 2 by what? By t. So if we do that, we are going to have t s equals to t into the s all over what? The p, keeping v constant, the p, plus t into the s all over the what? The p, the v, keeping p constant, the v. All right. So now we are going to rewrite this expression that I have here. The s is equals to, now we can decide to write this as t into the s all over the partial derivative of t into the partial derivative of t all over what? All over the p, keeping v constant, because we know this will cancel out, then we'll go back to this. I hope you understand. All right. Plus t, the same thing with this, partial derivative of s all over the partial derivative of t, keeping p constant, into the partial derivative of t all over the partial derivative of v, keeping p constant, v. All right. So if you look carefully, we know that what is here, this is nothing but cv. This is nothing but what? This is nothing but cp. So we can therefore replace them. So we are going to have Tds to be equal to, everything here is nothing but what? Cv. So we left with c, the partial derivative of t all over the partial derivative of p, keeping v constant, the p plus the p into the partial derivative of t all over the partial derivative of v, keeping p constant. All right. So the next thing we are going to be looking at is this. The next thing we'll be looking at is this. Now, look at this equation that we are having here. We know that what we have here will be taking this, the subject of formula, from the cyclic relation. You still recall your cyclic relation? We know that our cyclic relation is nothing but what? It's nothing but the partial derivative of p all over what? All over the partial derivative of t, keeping what? Keeping v constant, into what? Into the partial derivative of t all over what? All over the partial derivative of v, keeping p constant, into what? Into the partial derivative of v, all over what? All over the partial derivative of p, keeping t constant, everything equals to what? -1. All right. Now let's check the partial derivative of t all over the partial derivative of p. Okay, look at it here. We have it as partial derivative of p all over the partial derivative of t, inverse. All right, since it is inverse here, so let's decide to take the inverse of everything. So we take the inverse of everything that we have here. What are we going to have? So we are going to have this to be what? The partial derivative of t all over the partial derivative of t, keeping v constant, into the partial derivative of t, v, all over the partial derivative of t, keeping p constant. Then here we are going to have partial derivative of p all over the partial derivative of v, keeping t constant, also be equals to what? -1, because the inverse of -1 is still what? -1. All right, we can decide to make this the subject now, since it is what we need. So if I divide both sides by this and this, what will I have? I'm going to have the partial derivative of t all over the partial derivative of p, keeping v constant to be equal to minus 1 all over what? All over the partial derivative of v all over the partial derivative of t, keeping p constant into the partial derivative of p all over the partial derivative of v, keeping t constant. And if I take the inverse of this back, I'll go back to my normal equation back. So I'm going to say the partial derivative of t all over the partial derivative of p, keeping v constant, is going to give me what? The partial derivative of t all over the partial derivative of v, keeping p constant, into partial derivative of v all over the partial derivative of p, keeping t constant. But don't forget we have negative, so we have the negative sign. Okay. All right. So the next thing we are going to do is this. We know from our compressibility, our cubic equation and our compressibility equation. We know our K, our compressibility factor, is nothing but what? It's nothing but minus 1 over V into what? I don't know if you still recall that. Into what? The partial derivative of V all over the partial derivative of P, keeping T constant. All right. So we also know that our beta is nothing but what? 1 all over V into what? Partial derivative of V all over the partial derivative of T. Partial derivative of V all over what? The partial derivative of T, keeping P constant. All right. Now, here we have the partial, here we have the partial derivative of t all over the partial derivative of v, keeping t constant. That is, we have the inverse of what we have here, we have it here. So if we decide to make what is here the subject, what are we going to have? By cross multiply, I'm going to have beta v to be equals to partial derivative of v all over the partial derivative of t, keeping p constant, right? So for us to have the partial derivative of t over the partial derivative of v here, I'll take the inverse, right? So I'm going to have 1 all over beta v to be equals to the partial derivative of t all over the partial derivative of v, keeping p constant. All right, let's check here. Here we already have it as, this side we already have partial derivative of v all over the partial derivative of p, keeping t constant. Look at it here. If I make it the subject, mine is just to cross multiply, then divide by minus. I'm going to have this as minus kv to be equals to what? To be equals to the partial derivative of v all over the partial derivative of p, keeping t constant. So let's substitute these parameters in these two equations. So what are we going to have? We're going to have the partial derivative of t all over the partial derivative of p, keeping v constant, to be equals to, so don't forget we have minus into, so this one now, which is this, going to be minus kv multiplied by 1 all over what? Beta v. So this v we cancel out this minus will neutralize this, then everything will give us what? I'm going to have the partial derivative of t all over the partial derivative of p, keeping v constant, to be equals to what? To be equals to k all over what? Going to be equal to k all over beta. All right. So now the next thing we are going to do is this. You know what we have just done is we made this the subject of formula from the cyclic relation. We try to modify it, then we get k all over what? Beta. All right. The next thing we are going to do is this. We are going to make this the subject. We have the partial derivative of t all over the partial derivative of v, keeping p constant. The partial derivative of t, don't forget we have here, we have the partial derivative of b all over the partial derivative of t. Now, and sorry, okay, look at it. We've already made the subject of formula here as well, which is what? 1 all over beta b. All right, look at it here. So the partial derivative of t all over the partial derivative of v, keeping p constant, is already 1 all over what? Beta b. All right, so we are going to substitute for these two parameters that we have here. All right, so let me clean this side. So the next thing is just to make our substitution, then we are done. All right, so we are going to say Tds will be equals to Cv. Then the partial derivative of the t with respect to this is what is k all over beta. Then we have this as what Cp plus Cp. Then partial derivative of t all over this is nothing but what 1 all over beta. We have 1 all over beta multiplied by 1 all over beta v, then v. All right, so we can finally write this equation, this Tds equation as Tds to be equals to the vk all over what all over beta vp plus then cp all over beta v then dv. All right, so this is our third Tds equation. So in case you are asked to derive any of the Tds equation, I believe we have done justice to that for us. And if you are asked to apply them, we've also done justice to that. All right, so stay tuned as we deliver more content on thermodynamics relation. Trust us, we'll be solving many numericals, possibly all the numericals you are going to come across in your exam. We are going to solve everything here. So stay tuned. Don't forget, if excellence is attainable, then why settle for less? Why? All right, don't settle for less. Always stay updated. Don't forget to give this video a thumbs up if today is your first time coming across our content. And don't forget to share with your colleagues who might be in need